Good morning, students. Today we are going to explain the experiment of digital signal processing through the virtual lab. Uh, Here, first of all, we share the screens. How to reach the virtual lab? All of you students first open the Google tab and type the virtual lab and click the first tab, virtual lab. Look at this. The virtual lab tab is open. You can also click the electronics and communication branch. Look at this. Here, there are number of subject practicals are available. You can click the digital signal processing lab. The introduction of this lab, this digital signal processing virtual lab is initiative of MHRD department, which is the body of our government. Here, list of experiments also are available. Here number of experiments are shown. First experiment today, I will explain the first experiment, study of sampling theorem and effect of undersampling. Click this first experiment. Introduction. Before doing the experiment, first of all, you know about the how to view the real life analog signal with an oscilloscope. Second one is how to set the amplitude, frequency, and phase of the signal sources. Look at this theory of this practical. Actually, we are going to convert the analog signal into sampling signal. So first of all, all of you know about the real life signal, analog signals, which is converted into the digital signals through the analog to digital converter. Look at this diagram. Here the message signals are applied and you can get the quantized digital signal output. For doing the sampling, for doing the sampling, the important points of sampling, the sampling frequency is greater than or equal to the 2 times of the message frequency. Look at this equation, Fs greater than equal to 2Fm. If this criteria is fulfilled, then you can do the sample. You can do the sample of input message signal. Look at this diagram. For example, we consider an analog signal of frequency 1 kilohertz like this. If the sampling frequency is 4 kilohertz, the sample signal is shown in this figure. Note that exact reconstruction of missing sample is obtained so long as the Shannon sampling theorem is satisfied. Shannon sampling theorem is Fs is greater than equal to the 2Fn. But now let's consider the analog signal of frequency 5 kilohertz and sampling frequency is same error like 4 kilohertz. You can never get the, in this case, reconstructed signal has a frequency of 1 kilohertz. The signal of 5 kilohertz is folded back as 1 kilohertz into the range determine the sampling frequency, leading the problem of aliasing. In this case, aliasing effect is arising. Now move to the procedure. Now move to the, all students move to the procedure. Click on the experiment simulator lab. It is open in the workspace. See to the move in experiment page. Press to help to button if you need it. In the workspace, click on the browse block to understand how many following steps are to be executed. Now drag the sine wave generator in the left side. You can put the value of amplitude, frequency, and phase. Here we can put the value of amplitude 3 volt, frequency 19 volt, and phase equal to 0 angle. Now, then after drag the sampling block in the workspace, place it after sine wave generator to its right, click to parameterized, make sampling frequency 40 kilohertz. It will show number of samples as 80 per display. Now drag the scope in the workspace after sample to its right. For making the connections, to take the cursor to node provided in each block where from connection is to be made. Click on its circle and appear to the background. If pointed properly, yellowish time will appear. Click on the time enable connection. Connect the sine wave generator output to the input sampler by clicking the both block. Link will appear. There are following procedure you have to follow. Look at the output diagram, sampled output diagram. Now move to the simulator. This one is the simulator procedure steps. Here there are following steps to follow the simulate the program. First of all, observe the block diagram. Second one is the select the amplitude of input sine wave signal. Third one is select the frequency of signal FM. Fourth one is select the sampling frequency of the signal FS. Select the channel 1. Why we select the channel 1? To observe the input signal on the graph. Then after select the channel 2 to observe the sampled output signal YN on the graph. If you want to see both input and output, you can select the dual tab to observe the input signal as well as output signal on the graph. Make sure there are following factors. You have to make sure always input signal amplitude A greater than 0 volt. You have to also make sure about input signal frequency FM and FS greater than 0 volt. To change the value, just scroll the heading on it. First of all, you have to on the power. After on the power, you can look the function generator input voltage, message frequency and sampling frequency. First of all, you have to put the input voltage, input frequency, input voltage of the message signal like 5 volt. If you have to put the message frequency FM equal to 5 kilohertz, the sampling frequency is greater than equal to the 2 FM according to the Shannon theorem is equal to 10 kilohertz. Now, if you click the channel 1, you can see the output of input signal in the waveform. Look at this diagram is the input. If you click the channel 2, you can see the sampled signal output. If you click the tab dual, you can see the both input signal as well as sampled output signal in CRO. After that, you can measure the voltage time division through channel 1 and through channel 2. The students, I think you have understand this program. Thank you very much.